I'm going to go ahead and start. I'd like to thank everyone for coming to the Data Architecture Virtual Chapter today. Rayis is going to give us a great presentation. My name is Rob. Kenny's online helping me today. If you ever have a question, you can always email me at rob@SQL or Data Architecture at Pass. Let's see. So we got a discount code. So if you go on a Pass or the Summit and you use this discount code, you should get $150 off. There's a few caveats. You can't use multiple discount codes. But if you do use this one by itself, you'll get the $150 discount. So pass it along to anybody that you may think going to the summit. And if enough people go, we'll be able to give out a free, in the past, we've been able to get out a free session so that you can go and we have all these freebies that we can give out. So thank you in the past for doing it, and hopefully we can do it again. So we have a great sponsor, HVR. They sponsor the Data Architecture Virtual Chapter, and if you have time, you want to check out their software, there's a link there. They've been very nice, and they give us a lot of nice freebies to give away, and they really make everything possible so we can come to you every month and have webinars. So let's get to some community news. They're looking for volunteers, so if you'd like to volunteer for the summit coming up, there's that web link at the bottom. Click on it, and I'm sure there's going to be some information on how to get onto maybe a program committee or some type of committee. Another cool thing coming up on March 31st is the marathon on performance monitoring. So it sounds like a real cool marathon with a bunch of great seminars. So the link again is at the bottom. Check it out. Other good upcoming meetings, as you can see for virtual chapters, you're going to see ours here, obviously, but they have cloud virtualization, lots of great webinars are coming down the pipe. So if you want to sign up, go to the past website, sign up for them. And here's a few more. We'll just kind of scroll through these. And one thing that's really nice about PASS is they do have a lot of virtual chapters, and they all have great content. So we're the data architecture chapter, but they got data science, just cloud, etc. So there may be other great topics out there that you want to explore, and just sign up at the main site, and you'll get on an email list typically, and they'll send you information on attending these webinars. Upcoming SQL Saturdays. So these are some upcoming SQL Saturdays. Like in the United States, I see there's Phoenix, etc., Boston. So it's a pretty cool way to spend your Saturday. Go out and learn something about a topic you may not know, and it's absolutely free. Let's see. Oh, I saw this today. This is kind of cool. If you're looking for a career, they have a career center, and you can view jobs, etc. And just as we've been kind of consistency here, there's a link down here to kind of get more information about posting a job or looking up jobs. It's kind of neat. And finally, if you want to connect with PASS, here's some ways to do it. They got the Hashtown SQL PASS, different ways. YouTube, they have a TV. They're free memberships, so hopefully everyone will take advantage of this. All right, let me switch over right now. So Rayis is here today to speak, and first of all, I want to thank him for coming on to the Data Architecture chapter and speaking with us today.
Oh, thanks. Hi everyone, and welcome to this Data Architecture virtual group session on using Azure Data Factory mapping data flows to load data vault. So I can start then.
Yes, sir. You're good to go. Thank you.
Okay, great. Thanks. So I'm very thankful to this opportunity to share my experience and knowledge of working with Azure Data Factory and creating use cases to model and populate data vaults. My name is Rayis, Imayev, and I'm a data professional who likes data to be structured and well understood. The session will be filled with demos and practical scenarios It helped me, and hopefully will help you as well to look at the other data modeling techniques and data load and patterns. So without further introduction, let me start my session with the quotes. I wanted to start my session with the quotes. Data are just summaries of thousands of stories. Tell a few of those stories to help make the data meaningful. As much as I like working with computer technologies, I love working with real use case solutions where some of the technologies could be used. And I'm in favor of finding a problem and then just dedicate my efforts to solve it. So therefore, this session will be focused on creating a use case of populating data vault model with the help of Data Factory framework provided by Microsoft. And it's less about studying a set of technological features that are available within Data Factory, or it will be less about defining limitations that we may face with data vault modeling designs on its own. So the key takeaway of the session will be that to see that Data Factory is a technology and Data Vault is a methodology, and the talk will be about using one to support the other. So let me start with a quick overview of our session plan. First, we'll take a look at the Data Vault modeling basics and how it's different from other data warehouse architecture methodologies. Then we will review examples of converting a simple model into a data vault design, and then I'll take a brief overview of different features and capabilities that we may find within the Azure Data Factory mapping data flow, and then we'll create our big demo to create a data flow scenario to populate a data vault model. And if time permits, we will work on our second demo to show how we can do the incremental data loads in our existing data vault model. If I'm given with the task to design a data warehouse, what methodologies can I choose? The dimensional approach, made popular by Ralph Kimball, states that the data warehouse should be modeled using a dimensional model with star schemas, or it could be more advanced, like a snowflake schema as well. The more normalized approach, also called as a 3NF model, made popular by Bill Inman, states that the data warehouse should be modeled using an anti-relationship model, or just like a normalized model as well itself. And the data vault could be declared as a byproduct of both of these methodologies, where we can utilize transactional referential integrity and use almost like dimensions and fact tables, although they're named differently within Data Vault workspace. The Ralph Kimball recommends building a data warehouse that follows the bottom-up approach. In Kimball's philosophy, it first starts with the mission-critical data marts that serve the analytic needs of the business. Then those data marts integrate through so-called information bus to address the needs of departments in various areas within the enterprise. In a dimensional approach, data is partitioned into either facts, which are generally numeric transactional data, or dimensions, which are the basic reference information or descriptive data sets that gives context to the facts. And the key advantage of a dimensional approach is that the data warehouse is easier for the user to understand and use. Also, one of the main disadvantages of the dimensional approach is the data referential integrity of the facts and dimensions, and the process to load the data warehouse with this methodology becomes a bit more complicated, where first we need to populate dimensions, and then knowing what those surrogate keys are, that drives the population of the fact tables with those foreign keys within the fact tables. The Bill Inman from the other side recommends building a data warehouse using the top-down approach. In Inman's philosophy, it starts with building a big centralized enterprise data warehouse where all available data from transactional systems are consolidated into a subject-oriented and non-volatile collection of data. Then further along the way, data marts are built for the analytic needs of the department. The tables in the Inman methodology are grouped by subject areas that reflect general data categories, such as customers, products, or finance. And then the normalized structure divides data into entities, which creates several tables in a relational database. The main advantage of this approach is that it's straightforward to add information into database. A disadvantage of this approach becomes that of a big number of tables, and it tends to be a bit more difficult for users to know how those tables are related to, and also it tends to be a bit more complicated for the end users to embrace this big data model without a precise knowledge and understanding how the source in data is structured and the overall structure of the data warehouse itself. The data vault as a I would say like as an alternative solution becomes like as a hybrid data modeling methodology, which provides historical data representation from multiple sources and is designed to support various data changes. It's a hybrid approach, and it combines both the third normal form and the star schema in a sense. And just trying to follow the Dan Lindstedt's who created this data vault methodology. He stated that his approach to design data warehouse models is flexible, scalable, consistent, and it supports almost all the needs of the enterprise, or almost like all the data needs of the enterprise. So basically, the data vault becomes like as a progression of other data modeling methodologies with some slight changes on how we design the tables or entities within the data vault model and how we then populate the data or upload the data in our data vault. So basically, there are three types of tables. We have hubs. Basically, it's very narrow tables which are a container for the business keys, and also they also contain a hash key value based on the or so-called surrogate keys based on the value of the business keys. Then we also have the satellite. The satellite tables, it's basically the descriptive attributes for the information of the hubs, and basically anything that would help to describe a business key would go into the satellite table. So basically, that's the representation of the third normative form. And the links of tables, basically they're the table that define how each different business keys are related to each other. So like key takeaways from here: the hubs maps business key to surrogate keys, and satellite contains the descriptive context data of the business key, and link tables allows us to join between different entities. In this example, I have a dimension product table, which is represented with two tables within the data vault model. I have a hub table, which in this case is a container to hold a business key, along with two or more other additional service columns. Which one in this case is a hash value key for the product, hub product hash key, and a low timestamp to track the time when the record was inserted. And the satellite table contains every other columns except for the business key. And if we didn't have the hash value, then the load would require a lookup on the hub and links. And instead of sequencing means that we can load then this will help us to load the data in a complete 100% parallel way. We can run the ETL to populate both hubs and satellites and links in parallel with no dependency, so that all hubs and links and satellite table could be loaded at the same time. And in our particular case, with this product table, the new business key values, then this will result in creating a new record in both hub and satellite tables. And then further changes to attributes of the existing products will only drive changes or additions to the satellite table, and there will be a new additional version with updated columns inserted into the satellite table. So basically, this would look like a type 2 historical option to track changes on the entity level. This slide shows how we can connect tables with facts with their relational with their related dimension attributes. And here's the factor internet sales table is represented as an additional satellite table, and with the help of the link table, we can join facts with the dimensions in our Datable example. And the link table in this case helps us to define relationship between our helps as well as fact-driven satellite tables. And don't be scared by the number of the tables involved. Data Vault requires more tables, but it offers more flexibility. And again, I would like to emphasize a need to have a hash value key for the satellite tables. This approach is similar to the hashing of the business key on the hub table, but it only it reduces the effort during the upload process, because we in this case we only would need to take a look and compare only one column. And the satellite upload process first checks if the hash key value is already existing satellite, and then if there's a difference between the hash different value, in this case it sets, going back to our example, the satellite product HDF. This is the hash value which combines the snapshot of all the columns within the satellite product table. So if anything gets changed or becomes different, then the set product HDF column will reflect that change as well. And this is just overall. So from the initial set of 4 tables that I've taken as a small subset of the AdventureWorks database, I was able to create 9 tables in my data vault model. So now let's take a brief overview of the Data Factory. My first experience with Azure Data Factory was in 2017. At that time, it was the wizard-based framework to copy data from a source to destination and output, and the code was in the form of a JSON file at that time. And we even thought to use Visual Studio to update and maintain this code. With the latest or the current version 2 of the Azure Data Factory, visual user interface became the standard way to alter control flows. And also, monitoring options became very handy to analyze statistics of failed and successful ADF pipeline runs. So then, I'm coming from my experience of using SSIS solutions to do the ETLs, where I used to have my control flows and data flow tasks. And then the Azure Data Factory development practice became no different from having the same concept, where within the same data factory, I have both the control flows and mapping data flow as well. And in general, the ADF itself, I would say, has 5 main components. It has activities, it has pipelines, data sets, link services, and triggers. The activities itself represents a processing step in the pipeline. For example, you may use a copy activity to copy data from one data store to another data store. And anything available for you in the control flow panel could be called as an activities. Then a pipeline is a logical grouping of activities that performs a unit of work. Together with the activities in a pipeline perform a task. For example, a pipeline can contain a group of activities that ingest data from the Azure blob, then map and data flows to do further data processing, and then we can execute and schedule some of the Databricks notebooks if we need for any further analytical purposes. Data sets represent data structure. Basically, simply the point or make a reference to the data that we want to use in our activities as inputs or outputs. The link services defines the connection to the data sources that we want to utilize in our data factory development. They're the data connections to our data sources. We can use them in as our data interface points. And last part of the, let's say, main artifacts that we may find data factory are triggers. Triggers usually help us to start in ADF pipeline executions. there are different type of triggers for different type of events. We have file-based and we have time-related triggers as well. The mapping data flows on the other side are very similar to data flows in the SSIS. They have sources, they have sinks, such as like destinations, and transformation steps, or simply transformations. And let's take a close look at the sources for sinks and transformation in ADF mapping data flows. Data flow should have a start, an end, and source and destination, and beginning of your data stream and the end. Basically, a source transformation configures your data source of your data flow. When you design data flow, your first step will always be configured as source transformation to add a source. And then you click and add source box in the data flow canvas. And every data flow requires at least one source transformation, but you can add as many sources as necessary to complete your data transformation. Next part, sinks. Sinks basically defines, after you transform your data flow, you can sync the data into the destination data set, and you can have as many sync transformation as your data flow requires as well. And in your data flow, you can direct Data Factory to create a new table definitions in your target database as well. And then anything that you have in between the source and sinks, we can call it the transformations, or just basically transformation tasks. These tasks could be just like a derived columns, like we can join the different data streams with a union task. We can pivot on pivot. We can limit this subset with other filtering options or select options. So there's a growing number of options that we can utilize in order to leverage the transformation steps within Data Factory. So basically, within the mapping data flow, we have sources, we have sinks, and we have transformations. So let's now move to our demo when we would be creating our data vault model, and also we will create a data flow within our Data Factory to populate this data vault model as well. So before I go into my Data Factory, let me first show you the database I would use as a destination, as a target where I would need to populate. So I already have created a model. So these are those 9 tables that I had in my presentation. And for this particular demo case, we will try to create a mapping data flow to populate 2 tables, to populate the geography subscript tables, the hub geography and the satellite geography. So at the beginning, we have some data. So I'm going to truncate just to make sure that we would be populating, we will be bringing the source and data into these 2 tables with the help of Data Factory mapping data flow. So I'm going to just remove the data from these 2 tables. And also if I go, let me show how the source and data files are structured. So I have a storage account and I have a dedicated container for the source and files. And in this particular case, I will be looking at this flat file that I've created already, and I'll pull this data from the AdventureWorks data set. So basically, this geography data set is defined by the business key, which in this case is IP address, and all other descriptive attributes that define a geography of the customer. So basically, these are the source and files, and there we can start creating our mapping data flow. So I'm going back to my, actually want to save this for future references. I think that will work. Okay, so first I'll need to open the existing instance of my Data Factory. It may take a few seconds. Then I bring myself into the edit modes, and I specify my Data Factory is linked to my personal Git repository and a GitHub. So the very first thing I'll need to do is just for me to start creating a mapping data flow. I just need to make a choice that I'll need to create a data flow. I would specify, for this particular case, I'll be there are two options for data flow in Data Factory, but I'll be choosing the one that is not in preview, map and data flow. Click OK. And now I'm ready to do the very first thing. I need to create a data source. So in this case, I will be connecting to my data set from the blob storage file. So I'll just name it more user-friendly, specify geography. And I have already created my data sets from blob storage account. So I'll just need to select. So this is my data set from blob file. I can verify how the data file looks like, and I can go and I can even preview the data. So this is exactly the same file that I had before. Let me move this window away a little bit. Okay. And then I can close. Also, I will need to start my debug session as well. All right, so now I'm ready to add some additional columns. The next step in my case that in my use case to create a data flow to populate my data vault is to add some additional columns. In this case, I would need to add an additional task derived column, and I would say that I need to create a hub geography hash key. And I will go to the expression way to define the formula behind this calculated column, and I'll specify that the hash key will be driven by the value of the business key. In this case, a geography alternate key, which is in this case is the IP address of the geolocation of the customer. I click save. I click close. And I need to add a couple more columns. So I click the plus again, I add a column here. I specify that I need to add another column, which will be called set geography hdif. When I go to the expression editor, I would choose another hash function, not the same hash function. And I will specify that I will need to use all the attributes. State province name, country regional code, English region name, and the postal code. I click save, and I rename it within the same expression editor. I can add another column, which I would just name as a load timestamp, and I would assign just a current timestamp function. I click save. I click close, and here, going from the initial 7 columns, now I can see the 10 columns total, with including those the 3 columns that I just created. And I'll just rename this, so this will be my hash columns to be more user friendly. So then the next step in this case, I'll need to connect to add a new data set or data source, which would connect me to my hub geography table. So it's specified this is my new source hub geography. I will go with the geography in this case, and I already have data set defined by the my Azure SQL database, and I can go and check how this data set is defined. I go and specify, and I see that the data comes from my hub geography table, and right now it shouldn't return. Yeah, the table is empty, so it doesn't return any records to me. So I go back, click this. So now I'm ready to having this source and data stream and having the lower the reference point to my data from the hub. Then now I can compare and check whether there's any new records from the source file that I can push further down along the way to upload into my hub geography table. So in this case, clicking the add a new task exists, and I specify set the more user-friendly name and check new geography. I click doesn't exist. From my left stream, it's the data comes from hash column, and my right stream comes from the source object geography. Basically, it's a join between those two data sets where I specify where the condition columns. Let me move it, let me minimize a little bit so I'll be able to show. So the join conditional will be done by the geography hash key. So in this case, from the left stream, the hub geography, it's my calculate column that was creating hash columns, and this is the physical column that already exists in the data. So in this case, anything new that won't exist from the source will be passed through this checked new geography task. And then in this case, I'm fully ready to direct the output of this check new geography task into my sink. But I need to knowing that the schema of the table itself. If I go back and show you this, how the table is defined, there's only three, not the satellites, but the hub table. Since it has only 3 columns, then I need to limit the output of my check geography task. And specify this will be my new geography, and I would select all the columns, and I would leave the business key, the load timestamp, and the hub geography hash key, and the rest I can delete. And in this case, I'm fully ready to move forward and specify the output of my new geography select task into my sink. So then the last step for me to specify the complete data flow from the source to the sink, and in this case, I'll just name it properly, sink hub geography, and then I'll specify. So knowing that the source hub geography was based on the hub geography dataset, and the sink hub geography is based on the very same dataset. It's basically it shows the concept that I'm comparing the data from my destination table, and then with the source and the data file from blob, and if the data is marked as new, then this data will be inserted into the very same table, into my hub geography table. And on the preview, on the mapping table, I can see the proper mapping. It's 1-to-1. And I have an option as well, like to see what will be the potential output of this very exercise. The data preview doesn't do the actual the data movement. It just it previews the output or the outcome of all those. In this case, it's 5 transformation tasks, and each of those different tasks they have their own data preview options. So in this case, I will be able to see 3 columns in a few minutes, in a few seconds. Yeah, so in this case, it showed me, okay, this will be potentially the output. And similarly, I could see what will be the output from my hash column. In this case, it should show me 10 columns. So now I'm halfway through. I've created the part of the data flow that populates data into my hub table. And now I can move forward and staying within the same data flow task. I can even give a more user-friendly name. So it would be like data flow, data architecture, virtual group, pass. Then I can finish creating, updating the very same data flow, and I can add all the other necessary transformation tasks in order to populate my satellite table, satellite geography table. So in this case, I will be relying on the very same output of my hash column data set, and for this, I would just need to create a new branch. The new branch will help me to reuse the output for the other transformation steps. Basically, it's like it's a branch. Well, yeah, it is a branch. It basically replicates the outputs into a different stream. In this case, I don't need to recreate this source data transformation. So now having this one, having the replica of my hash columns, I need to create a source to my satellite table, satellite geography. In this case, I would say source set geography latest. And I have already the latest definition for my geography. The geography itself, it only has two columns. It's knowing the idea behind the satellite table. Let me just move myself into my data studio. So the satellite table, it's a combination of the hash key of the business key from the initial source and data set of list of IP addresses. Plus, it also contains the sat geography hash difference. And in this case, I would need to define always the latest version of the snapshot for the combination of records. So for the hub geography hash key and for the satellite geography hash difference. For this very purpose, I have already created a view, which basically it may not be the best T-SQL script ever. There's an alternative way to do this the same way, but basically I'm returning those two columns and I'm returning the latest record based on the value of the load timestamp. So technically, this helps me to provide the latest records. Let's say a person's name could have the first and last name could be like John Smith. Let's say then the second iteration will be like John Smith 2. And then with the third update, the John Smith 2 will be updated back to the John Smith. So in this case, the latest updated record will be John Smith based on load timestamp. So I'm going back to my definition of the source and data, sat geography latest, and I'll be doing the very same thing. We'll try to check for the existence. I'll check exists. Now say check new set geography. The left string will be the same hash columns, and the right string will be their source set geography latest. I'll specify that it doesn't exist. And in this particular case, let me try to minimize a little bit more. In this particular case, I would need to set two columns for my join condition. So it'll be the first one will be hub geography hash key, and I'll add the second column, which will be the snapshot or the snapshot of all the descriptive attributes of my business key. Right, I'm ready, and also knowing that this check the exist option enables me with to add a sync transformation step, but knowing that my satellite table only that has 9 columns, so I need to in a similar way to limit my data sets. So it's say new set geography, and I just need to remove the business key from my source and data, which doesn't exist. Let me just show it again. So the business key only exists in the hub geography table, but this alternative key doesn't exist in the satellite table. So now I'm fully ready. Having 9 columns, I can sync this data into my sync set geography, and I would say geography satellites. I can check whether the mapping is done properly, so it's 1-to-1. And I can either check the preview, or I can save this particular data flow, and I can go ahead and start doing the actual testing. So for me, once I finish, so again, let me review my data flow again. So as you can see, I have the at the top of my data flow, I see all the transformation tasks that enables me to populate my hub table, and then we're using the very same data set from the exactly the same source geography blob file. I can check and see the non-existent facts or non-existent events, which then would be moved down within my data flow workflow and will be sunk or will be populated into my sync satellite geography table. Just want to make sure to double check whether my check is done properly. It doesn't exist. It doesn't exist. I save this file. Then I have already for me to test the data flow, I need to go back and create a pipeline or add a reference to this data flow within my plan. So I already have mapping data flow task. I can either add a new pipe or add a new reference, or in this case, I already have the data flow activity within my pipeline, and I can just change the reference. So in this case, I will move my data flow to I should be able to see the data flow that we just created, the DAVG pass. Click Save just for the reference, and I can click the debug. So behind the scenes, though, since I've enabled the data flow debug integration runtime, so there will be internal Spark cluster that will like an internal engine behind the mapping data flows that will do all the actual data transformation. So, and if I can see the progress, I should be able to see. So I can click those class buttons. So I can. This is a really nice view for me to see the progression of all the individual tasks within my data flow. So if I hit refresh, I can see that the initial source and the blob file from my storage account has 655 records. So the same number of records went through the hash columns, and I should be able to see the progression to all other tasks in a few seconds. So yeah, so then in this case, the source hub geography was empty, and then since there was nothing in the source hub geography, then exactly the same number of records, the 655, went into my final sync hub geography. And in a similar way, I should be able to see that the satellite table was populated with exactly the same number of 655 records. And it should give me the total green light that my data flow was successfully finished. I think it's finished, but it should give me some highlight. And I can, in this case, I can go back and check my tables in this case. I can run and validate the data. So now I can see the data. The data was populated. So this helped me to do the initial data loads from this sourcing file into my data vault model. So let's now go back and try to create our second demo with, let's say, with sort of like an incremental data change. In this case, I'm going back to my blobs storage accounts to the same container, and I'm going to make a couple more changes to my sourcing data vault stage and geography CSV file. So I'll click the same file. The file is fairly small, so I can edit within my Azure portal. Otherwise, we'll have to make updates out differently. So in this case, let me try to find, say we have one address within the Manitoba Canadian province in Canada. So I'm going to make some changes to the one of the textual descriptive attributes for the existing entry. So in this case, I'll just add additional BA characters. It'll be like Manitoba, blah, blah. And also, I'm going to add a totally new entry. Let's say with the where the business key will be new. Like in this case, it won't exist in my target destination environment. So, and I'm going to just make it as BA as well. So in this case, my computation will be that with these two new changes, there will be a new record added into my hub geography table with this information, with this IP address, and there will be two new records inserted into my satellite geography table. where one will be a second version for this very business key, but with different information for this set of columns, and there will be just a corresponding record for this particular business key. So I'm going to click Save. Now, in my case, I will be reusing the very same data flow. I don't need to create an alternative or any additional data flow, but I'll be just will be running and testing exactly the very same data flow workflow to test whether the incremental changes will be properly populated into my data vault model. So I'm clicking debug, and this will be our latest demo for today's session. I'm clicking refresh. I'm going to my glass mode. By default, I think every 20 seconds it'll be automatically refreshed, I think, or every 60 seconds. My mistake. Or otherwise, I can still press the refresh button manually. So in this case, I still can see that in this case, one more record was marked as introduced since I've introduced one new entry, the 656 record. The source in object table in this case contained the previous loaded 655. So let's see how there goes. What will be the progression of this? So on the workflow to populate my hub table, I can see that only one record was marked as new, and this proved our case. Only this record, the Manitoba, was loaded as this IP address. And if I go back to I click refresh, then yeah, the data flow was finished, and here I can see that only 2 additional records were inserted into my satellite table. I can just for the sake of I can validate, and I can check the relevance, or let's say if I can specify, or I think this should be the state province name, like Manitoba. Let's see how it's going to work. So now I see 3 records. In this case, the third and the second and the first and the third one, they correspond to the very same hash key, or the very same business key, and it does reflect the change. The first one, there was the proper name Manitoba, and this the third one, third records, the second version, the same record with some additional changes, and it also reflects the timestamp when the data load was done. So it was like in 4 minutes, that time difference. And I can also check, let's say I can get crazy and check how many records I have. I shouldn't have more than 2 records. So that's probably the case. So I see that it only reflects the 2 business keys, the initial one and then the additional entry that I've just created, like the fake record for the IP address. So this concludes my demo. So I'm going back to my slides, and this will be almost like the end. So we were able to go through the we've looked at data vault modeling basics, and then we've had also several examples of converting our simple data model when we've discussed this as well. Then we also reviewed data factory map and data flow capabilities, and then we've created 2 demos to do the initial data load, and then to perform the incremental data loads into a data vault model. So basically, the conclusion, I would say that data vault model, it supports so-called, as the term, like massively parallel persistence, since we no longer have a dependency to populate first the dimension table and then the fact table, so we can run the ETL on the very large data sets in parallel, so with no dependency whatsoever, because we would rely on the hash key. The hash key this surrogate key based on the business key that will come from the sourcing data and the hash difference key values, which would then combine all the textual attributes within the satellite table. And just as an additional note, that data vault is just a methodology, like it's one of many other methodologies that we can use in order to design our data house models. And again, and also Data Factory is just one of the tools that with mapping data flows is one of the tools that we can use to populate our data vault models. So basically, this is the end of my session. My name is again Rayis, and I do thank you for attending my session. This is a brief bio about myself. I currently work as a senior data engineer at the pension fund, OMERS, with the head office in Toronto, Canada. And you can follow me on my Twitter accounts, and you can also check my blog site with the help of those two links. Thanks again. I guess if there are any questions that I think we have a few minutes left, I'll be more than happy just to answer them.
Yeah, there are a couple of questions in here if you've got a few minutes.
Sure.
Let's see. I'll scroll up to the top here. First one, is Data Vault part of the Azure suite?
No, it's just a methodology. We can define data vaults technology agnostics. You can use I think any other vendors, whether it could be relational like database engine, or it could be just a pure data vault model based on the database tables, or maybe just some tables defined with data files within the data lake storage account. So it's just a methodology. It's not linked to any particular, say, technological solution providers.
Okay. Let's see. Oh, here's one. This is a long one. Is there a way to stop the execution of an ADF pipeline which triggers the execution of several child pipelines? You may want to read this one yourself in the question pane if you can see it. So that the children are stopped immediately without having to stop them individually.
Well, let me see. I'm trying. It does make. Well, I'm trying to go back to my questions again. Okay, this. I'm going to maximize. I can see it now. I know that. Yeah, I know that there is an API to trigger, like to start the execution of the pipeline. There is a trigger to. And I believe I haven't explored the API way of managing the resources, and also like API way to create resources, like create new data factory and then create new artifacts within data factory itself. But if anything that is available within the UI, where we can cancel even the main pipeline with all the cascaded sub pipelines, then we can technically utilize the API. The REST API way of doing the same thing as well. I believe it's possible, but I haven't explored that option too.
Okay. The next one is, will hash key comparison add any load on the data flow and pipeline runtime? The addition of having to compute the hash keys, I'm not sure.
Yes and no. Well, yes, and for the initial computation, it only will be required for us to do the initial compute cost to calculate the hash value. One will be first calculating the hash value from the sourcing side, and then once the value is there, let's say in the staging data set, then we will be just technically compare with the already pre-saved hash value on let's say on the materialized data set from my target destination. So in this case, my second iteration with the incremental data loads, my hash value will already staged in my hop geography and satellite table. So I no longer had a need to recalculate, and the values were already there. I just need to make sure that those values will be pre-calculated as well. It does add some, I would say, compute efforts from my database engine. I'm just thinking, I lost my mind. But basically, if this will become more efficient in a way that's where I would be going to more traditional way to create my surrogate keys with a sequence, and in this case, I'm having them as a sequence, but then I also will have to add an additional logic to find the corresponding surrogate key both in my dean table and in fact table, and just make sure, okay, whether this this particular business key value does exist or doesn't exist. So just to removing the complexity of or dependent way to create the ETL, I'm just the data vault it just brings us as an additional step to create a hash value on that load. And I think we're getting in, we're bringing ourselves into the environment where even on a large scale, let's say we can scale up very large Spark clusters that would help us to calculate the hash value very easily. So it's no longer an issue.
Okay. Let's see. There are a couple more here. More about data flows. Can data flow be parameterized with table names and possibly columns? I guess instead of hard coding.
I've seen there's a Mark Herman from Microsoft. He one of the main I think just the main leader of the Azure Data Factory, and he provides all the updates, in particular mapping data flows. I've seen one of those. There were a few blog posts regarding the pass and parameters. I haven't explored that's option as well, but definitely I believe it's possible to set the parameters, because if we can set and define parameters on the level of the pipeline of the regular data factory pipelines, but I think then this could be done also on the map and data flows. With the table names, we can there's a multiple way to rely on either like leverage the business requirements. So if either changing sourcing data, we can utilize the schema drift option, or in the case of there's a very nice feature when we create utilizing the copy data task, when we can specify and we can even set the name of the table, and then the copy data task will check if the table doesn't exist. It'll have with sufficient permissions from the data set, I'll just create that table on the backend, and then we'll push that data into a destination target environment. Column arrays, or possibly column arrays. Array just on the level of data factory, yes, we can set variables. We can set parameters, I think, I believe, as an array as well. The array, I think, is the array definition is done just like in a similar way, like the JSON, in a JSON format, or we can just use internal expression or functions. We can build the array based on the value that we can retrieve from the sourcing data. So we can definitely play with parameters and variables of the array type.
Okay. And then there are two more. The first one is how do you track deletes in a data vault?
If delete is required, it's a good question. Well, basically, the data warehouse from a data perspective, we can find a way where we can let's say we can add some additional, let's say, going back to a traditional way where we can specify, let's say, like additional flag into our satellite table, where we can specify how we can retire a particular hub, or in particular, let's say, we can set, okay, that particular hub record is retired, and then all the corresponding records will not be available, and then it'll be just a matter of of the consumer to properly know and how we can filter those records out. Basically, if there's a business need to physically remove records, this will be one case. But logically, we would need on the data warehouse, we would need to have an ability to audit and track all the changes. So that's with additional service type metadata, we can enable this type of a use case where, let's say, retire and deleting data within the data vault model.
Okay. And then the last question we have is, in a data vault with a huge number of objects, is there a way to generate the ADF data flows instead of having to develop them all manually?
We can do it manually, or we can do this. There's a way, like it's similar to Data Factory. Let me show it to you. So let me move this away, close this guy. So going back from Data Factory, so the Data Factory pipeline is just a pure JSON definition. So if we can find a way how we can recreate this JSON for the pipeline, then we can automatically recreate the initial, say, top level like workflow. And in a similar way, my data flow could be seen in a way of a JSON definition here, but it also could be done through the script task. I haven't explored this script task, but in this case, from the top I can see all my source entities with the 7 columns. I can see all the consecutive, all other tasks, all other my direct columns. So if I can write a framework that would create, let's say, method-driven data flow, then yeah, then definitely it is possible. Because I can see the actual scripting code of both my data flows and my and mapping data flows and data factory pipelines. I hope this answers the question.
I think so. That makes sense to me. That is the last of the questions that we have. Rayis, thank you again very much for speaking to us today. Really appreciate it.
Thank you, and thanks again for attending my session today. And I wish everyone to have a great journey building data vault models and using the mapping data flows in Azure Data Factory. Thank you.
Oh yeah, I know. I'm gonna pull my own recording tonight, and I'm gonna watch this again so I can just review.
Okay, great.
Really appreciate it.
Yeah, feel free to reach out if you. I like to explore all the new features, and Microsoft keeps adding new additional components and transformation tabs into the mapping data flows as well. So it's a great framework.
That's awesome. All right. Well, thanks again. Thanks everybody for joining us. We will see you again next month with John Deirdre, I think. All right. Have a great day. Bye-bye.
Thank you.